Welcome to GAME students. Gross and microscopy explained. In view of the shortage of time and the fast advancing university exams, I had chosen a couple of slides for the day, which are both intricately interrelated. The first is microfilaria, more in the domain of parasitology and microbiology rather than pathology. However, it is a very frequently asked question. There are two cycles, other two parts of the cycle, one in the human and the other in the mosquito. In the human, you have got the adult form, whereas in the mosquito, you have got the larval form. From the adult, you get what is called the microfilaria and the larvae. The larvae itself is of three stages, stage 1, 2, and 3, from which it re-enters human being and gets into the circulation, preferably the lymphatic circulation, where it grows and the cycle continues. There are different species of the microfilaria, and the first one is of paramount importance to us. One is the Wuchereria bancrofti. The others you people should know, Malay, Loa Loa, Onchocerca, etc. Basically, the microfilaria species can be divided into the sheathed and the unsheathed. You find that the first three are sheathed, whereas the others are not. Even amongst these, there is a subtle difference between Wuchereria bancrofti and the others, which we shall again be repeating. This is the cephalic end and this is the caudal end. I hope you are able to decipher the importance of it. What are the diagnoses? Very difficult word. I hope you have made it. There are two reasons. Not that the leg is as big as an elephant, but then the hide of the skin is as thick as the elephant's. And it is called as pachyderma. And elephantiasis, filariasis of the leg, usually it is unilateral, and you find that there is a non-pitting edema that develops. Please try to appreciate the organism. As I mentioned earlier, it is a cephalic end and this is a caudal end or the tail. The cephalic end is more blunt, and the body itself, it has got multiple nuclei which go rather up to the tail, and the typical end of the tail is free of the nuclei. This is something that we will have to remember. And there are graceful sweeps. You find it is quite beautiful as a ballet dance when you see a wet mount. This will be a picture that will be projected for you under the microscope, quite easy to diagnose. A long organism, multiple dots, violetish in color, against a background of RBCs. None other than Wuchereria bancrofti, the microfilaria. So here again, the tail is free of the nuclei and you are able to make it. These are the parts of it, kindly do it. There are some rings called the nerve ring and then the anal port, which we should remember as parts. The parts of the microfilaria will add some kind of tempo to our answers. This we have already seen. Compared to this, there is something else. Here, I am not able to see the organism, yet I am able to see the organism. This is called a wet mount. We take the blood of the patient and then put it directly under the microscope and a cover slip. We find that there will be a whipping and a swimming movement of the organism which cannot be seen, but then the RBCs will be pushed here and there. That is the purpose of the wet mount. The organism is alive, it is not stained, but can be seen as a wet mount. The parts of the organisms we had already mentioned, can we recollect? This is the cuticle or the external one, and then this is the body. So it is commonly found in the lymphatics and the blood. It has got a blunt head, a tapering tail. The body measures about 290 microns in length, whereas including the sheath, it comes to about 360 microns. The width is about 6 to 7 microns. There is a chorionic envelope. In other words, the envelope is derived from the chorion. Here, there are the R.A.T.S cells, there is a nerve ring, an anal pore, which you people will have to remember. And these are the nuclei, and the caudal end is free of the nuclei. It is a sheathed organism. And this particular diagram is derived from this source. Thank you. I hope you are able to understand this. So this is the elephantiasis that we have been talking about. And this again, it is a problem not to you people as undergraduates, though rarely it might be kept. But then I am finding cut surface of the organism. And these are all in the lymphatic channels. The empty space behind is a lymphatic channel. What happens is, owing to a chronic inflammation, there is a perilymphatic fibrosis or a perilymph nodal fibrosis. As a result of which, the lymph cannot be drained, there is an accumulation of fluid, and the fibrosis continues. Hence, you get what is called as elephantiasis or a pachyderma. We shall go on to the next game. This is quite simple, though. It can be asked as a question in various formats over here, and it will be very bad on our part if we cannot answer this question. Basics are basics, always. When you are asked a count, there are two counts that you should give. One is the differential count, and the other is absolute eosinophil count. The differential count, it is normally about 1 to 6%. Whereas the absolute eosinophil count, easy to remember, 40 to 400 cells per cubic millimeter. It is composed of a nucleus which is spectacle shaped or bilobed. But then this should not be the answer for. Eosinophil is identified by means of, look at the color of the granules. I find that there are some reddish granules. We call it as brick red granules with which we are supposed to identify. Because a neutrophil can be having 2 lobes. Sometimes a eosinophil can, this is also a eosinophil, but it is having 3 lobes. It is usually seen in allergic reactions, and it elaborates a lot of substances such as histamine, eosinophil peroxidase, eosinophil cationic protein, and major basic protein. These are all important in the infestation and the destruction of the parasites. Important in type 1 hypersensitivity as well. This particular diagram, I think you people will be able to remember and draw. Spectacle shaped brick red granules, larger in size than the RBC, than the neutrophil. Comes to around 14 microns. And the causes for eosinophil shall be major headings first. Allergic diseases, skin diseases, parasitic infestations, hematological. Under allergy, you have got bronchial asthma, hay fever, urticaria, rhinitis. Common diseases, but then you prepare your own list of answers so that you answer without any flaw. In the skin, you have got eczema and bullous pemphigoid. By any parasitic infestation, there will be eosinophilia, filariasis, ankylostoma, or the tapeworm, echinococcus, Ascaris lumbricoides, or the roundworm, pulmonary disorders. And there is a syndrome called as the Loeffler syndrome. It is actually a form of pneumonia that is seen in migratory parasites. And the patient can be having a eosinophil count as high as 2000 per cubic meter. It is called as eosinophilic pneumonia or Loeffler's pneumonia. Hematological disorders, please do not answer this as the first cause. CML, eosinophilic leukemia, and hypereosinophilic syndrome. These are all, some can be seen, but then whenever you give the answer the common things first and later the more difficult ones. So this again is a eosinophil identified by means of the brick red granules, which more or less matches the RBC. You can look at it in the peripheral blood, in the bone marrow. It can be seen in the lymph nodes and in the GI. The functions: killing of the parasites, type 1 hypersensitivity, mast cell degranulation, as well as the production of free radicals. This is a beautiful diagram which you people can draw, and I have shown this for comparison. A eosinophil having this granules and neutrophil having almost colorless granules. Please compare. And there is a condition called as eosinophilia, where the count is decreased. It can happen in any form of bone marrow suppression or in ACTH administration. In these conditions, I hope you will be able to recollect all the subheadings and answer. Please write these and draw these. See you in game 47.